Hello, Namaste. This is Nikhil and welcome to PP's Learning Lab. And in the last session, we discussed how to find, what are the basic concepts related to the power series solution of ordinary differential equations. Like what are the standard methods to find the differential equation, solution of ordinary differential equations or having variable coefficients, like power series method and Frobenius method. And we also discussed ordinary point and the singular point, and in single point we discussed regular single point and irregular single point, right? And in this video we are going to discuss how to find the solution of given ordinary differential equation having the variable coefficient using the power series method. Using power series method. If you want to find the solution of given ordinary differential equation with using power series method, then there should be x equal to x naught, that's ordinary point should be 0. For x ordinary point equal to 0, we use power series method to find the solution of ordinary differential equation using the variable coefficient. Let's recall what we mean by ordinary point. Ordinary point is a point in which if y double dash plus p of x y plus y, so q of x into y equal to 0 y dash. So in this equation, there is a variable coefficient of second order differential equation. In this equation, if p of x and q of x should be finite at a particular positive integer x naught, then this is said to be ordinary point. X naught is said to be ordinary point to be given ordinary differential equation, right? So if to use power series method to find the solution, the x naught should be 0. That is, ordinary point should be 0. Let's see what are the basic steps that are involved to find the solution of ordinary differential equation using the power series method. First step, we need to check whether the given differential equation having the ordinary point as 0, so that we can solve the question using the power series method. This is the first step. And if it is having x equal to 0, x not equal to 0 as an ordinary point, then the solution will be in the form of y equal to summation n equal to 0 to infinity c n into x power n. And secondly, thirdly we need to find y dash, that is n into cn x power n minus 1, that is summation n equal to 0 to infinity, and we need to find y double dash, that is summation n equal to 2 to infinity n into n minus 1 into cn x power n minus 2. Here is the first step. We need to find whether the given ordinary point is, whether the given differential equation is having the ordinary point as 0. And secondly, we need to find y dash and y double dash. And then we need to substitute in the given differential equation. Thirdly, we need to substitute y dash and y double dash in the given equation, right? And then we need to solve the equation. Then we get in terms of y equal to c naught into y of 1 in terms of y minus plus c1 into y2 or c1. We will finally get the result as this. By if you solve the given differential equation by substituting this y dash and y double dash. Let's do one example, guys, and it will be more easy for us. d2y by dx square plus x into dy by dx plus y equal to 0. So I can write it as y double dash plus x into y dash plus y equal to 0. So it's clear that at x equal to 0, at x not equal to 0, this p of x and q of x is 1, right? So here p of x is x and q of x is 1. So at x equal to x naught, that is 0, p of 0 is equal to 0 is a finite value and q of 0 also a finite value, not infinite value, right? So we can proceed, we can move on to find the solution of the given equation. The first step is y is equal to summation n equal to 0 to infinity Cn x power n, right? Then y dash equal to n into Cn x power n minus 1 and y double dash is equal to n into n minus 1 into Cn x power n minus 2. Then we need to substitute this in this equation. Y double dash क्या लिखना बेटा? Summation n equal to 1 to infinity summation n equal to 2 to infinity. Now we need to substitute y dash and y double dash in this given differential equation. So what we get? Summation n equal to 2 to infinity n into n minus 1 Cn x power n minus 2 plus x into summation n equal to 1 to infinity n into Cn x power n minus 1 plus y, that is summation n equal to 0 to infinity Cn x power n equal to 0. See here, summation n equal to 2 to infinity n into n minus 1 into Cn x power n minus 2 plus x into summation n minus 1 n equal to 1 to infinity n into Cn x power n into x power minus 1 is x power n into x power minus 1 plus summation n equal to 0 to infinity Cn x power n equal to 0, x and x power minus 1 got cancelled. Then finally what we get is summation n equal to 2 to infinity n into n minus 1 Cn x power n minus 2 plus summation n equal to 1 to infinity n into Cn x power n plus summation n equal to 0 to infinity Cn x power n equal to 0. So to solve this expression we need to make all the x powers as same, that is x power n minus 2 and x power n ये लेना सेम है. So यहाँ पे तो n minus 2 है ना, n minus 2 का जगह n लेना पड़ेगा. So in this whole equation n का प्लेस में n plus 2 लिख लो, ठीक है ना. So what we get? Summation n is equal to 2 to infinity n plus 2 लिखना ना, n plus 2 into n plus 2 minus 1 into C of n plus 2 x power n plus summation n equal to 1 to infinity n Cn x power n plus summation n equal to 0 to infinity Cn x power n equal to 0. And here what we need to do is, in this step we need to, in next step we need to take all the coefficient of x power n and we need to equate to 0. That is n plus 2 into n plus 1 into Cn plus 2 plus n into Cn plus Cn equal to 0, right? So as Cn is high, Cn plus 2 is highest, make this in this side and bring all the terms to that side. So what happened? N plus 2 into n plus 1 into Cn plus 2 equal to minus of Cn plus n into Cn. Next step, Cn plus 2 is equal to minus of Cn plus n into Cn whole divided by n plus 2 into n plus 1 From here, what we need to do is we need to find the value of C0, C1, C2, C3. Put n equal to 0. Then we get C2. C2 is equal to minus of C2, sorry, 0, right? C0 minus 0 divided by 2 into 1. So what we get? Minus C0 by 2. Similarly, we need to find the value of C3, that is n equal to 0, C2 value. N equal to 1, we get C3 value. C3 value is equal to minus of C1 minus, sorry, C1 minus plus C1 divided by 3. 3 to the 6, so we get minus 2 C1 divided by 6, that is 3, that is minus C1 upon 3. Similarly, we need to find the value of n equal to 2 is equal for n equal to 2, that is C4 and so on, n equal to 3 and so on. By substituting n equal to 0 in this equation, we get C2 is equal to minus C0 by 2, and substituting n equal to 1 we got C3 equal to minus C1 by 3, and by substituting n equal to 2 we got C4 equal to C0 by 8. If we get into C2 in terms of C2, but C2 we have minus C0 by 2, then we get C0 by 8 and so on. If we do on, then we get C2, C3, C4, C5, C6, C7 and C6. Up to here is bus, more enough. And finally what we need to do is, we need to substitute these values in the y is equal to summation n equal to infinity, n equal to 0 to infinity Cn power x power n. That is, if we substitute n equal to 0, ये क्या हो जाएगा? Cn C0, sorry, C0, and if we substitute n equal to 1, then C1x. If n equal to 2, then C2x square plus C3 x cube plus C4 x to the power of 4 plus C5 x to the power of 5 and so on. We got C0 and C1 ऐसा रख लेना, and C2, C3, C4, C5 in terms of C0 and C1 term में लिखना. ठीक है? Then what we get? Y is equal to C0 plus C1x plus C2. What is the value of C2? C2 is minus C0 by 2. That is minus C0 by 2 into plus into minus minus हो जाएगा into x square plus C3. C3 is minus C1 by 3 minus C1 by 3 into x cube. C4 can be written as C0 by 8, C0 by 8 into x to the power of 4 plus C5 can be written as C1 by 15, C1 by 15 into x power 5 plus so on. So we need to separate the C0 terms and C1 terms. Then we get y is equal to C0 बाहर लेके आना तो 1 plus minus 1 by 2 x square plus 1 by 8 x to the power of 4 plus so on, plus if we take C1 outside, then we get x plus x minus 1 by 3x x cube and then plus 1 by 15 x to the power of 5 plus so on. So C0 into a function and C1 into a function. So y is equal to C0 into y1. We can write it as y equal to C0 into y1 plus C1 into y2, where y1 and y2 are the solutions of given second order differential equation. Thank you.